Hi and welcome to the channel. In this video, I'm going to walk you through how to solve the palindrome question. And basically, my goal with the video is to help you come up with your own solutions when you are faced with technical questions and not necessarily just to present you an answer. Obviously, we are going to solve them, and I'm going to show you 3 different ways to solve them. But as I said, the goal is for you to be able to appreciate how to come up with the solution and not just necessarily presenting you the solution. So I came up with 3 different methods to solve it. Some definitely are more efficient than the others, but then our focus is how do we get a working solution. So we are still going to go through all the 3 methods, help you analyze them and come up with a solution by yourself. So the question that we have been given is given an integer x, return true if it is a palindrome and false otherwise. So the first thing you want to appreciate or pay attention to is what a palindrome is, because that is essentially what the question is asking. If you know what a palindrome is, then you now go and see how do I know the number is a palindrome. So basically, a number is a palindrome if when we read from right to left, it is the same as reading from left to right. So basically something like this 1 to 1, where if it is read from right to left, it still reads 1 to 1. If you have -1 to 1, it is not a palindrome, because when you read it from the other end, it becomes 1 to 1 minus, which is not the same as -1 to 1. Then if you have a number like 10, it is not a palindrome, because when you read it in the reverse order, you get 0, 1. So how do we build a solution for it? The easiest way is for us to reverse the number and compare the two numbers, the reversed one and the original number. But unfortunately, there is no easy way to reverse a number in any of the programming language. You have to run a loop to get it done. So we'll probably take a look at them. But then the easiest way that we can make away with is to convert the number to a string. So convert to string, then we reverse the string, because there are a lot of methods that can be used to reverse the string. So the first thing we'll do is convert this number, convert num to string, then reverse the string. That will be the next thing, reverse string, then compare the two. So compare the two strings. If you compare the two strings and they are the same, then return true. If they are not the same, return false. That is like the easiest way to solve it. So let's see how this is implemented in code. In code, as you can see, the string method, I've defined a function called a palindrome, and it takes the parameter num that will represent the number that will be passed to it. Then you saw earlier that if it is negative, then it's not a palindrome. So that's the first thing. We don't want to waste time going through all the conversion if it is negative. As soon as we enter the function, we check if it is negative, return false. Otherwise, we continue to convert the num to string. So I'm using Python. You can use any programming language, but the Python, this is the method this is the function we use to convert an integer to a string. So the str function or str function will convert your num to string, and we are storing it in s. Then I'm going to reverse the string. I'm using the slicing notation in Python, where I say, okay, I want you to go through this string starting from one end to the other, but in the reverse order. So that means start from the end to the front. That helps me reverse it and save it in this new string here. Then I go ahead to compare the two of them. So if the two strings, the reversed one and the original string that I got from here are the same, then this expression will evaluate to true. If they are not, it will evaluate to false. So if you pass 1, 2, 3, I believe 1 to 3 should reverse to 3 to 1, which is not the same as 1 to 3. So we are going to get false if we run it. Python, then palindrome 1, run this, and you see it is false. Now let's change this to 1 to 1. which is supposed to be a palindrome, and run it to see, and that is true. So basically this is a string method. Let's go back to the second method. All right, so with the second method, let me walk you through the thought process. Let me just name it second method. You have to know how numbers are built to be able to solve it. In fact, where I picked this question from, there was a caution that you should solve the problem without converting to string before. So I feel that this is not the most appropriate solution, but then it's a working solution anyway. So the next method is we are not going to convert it to string. So how do we work with the integer without converting it to string? Let's take this example. 1 to 1. We are supposed to appreciate how this 1 to 1 is built together. Assuming I gave you three numbers, 1, 2, and 3, and I asked you to generate 123 out of these three numbers, how are you going to put them together? Okay, so mathematically, what is going to happen is that, let's say my new number that I'm going to get is equal to 0. Okay, that's, we are starting from 0. I want to add these numbers to eventually get 1 to 1. So if I'm starting from 0, y is equal to 0. The next thing will be y is equal to 0 times 10. Okay, you pay attention, you appreciate this one. I'm just showing you how this is done. 0 times 10 plus, what is the first number that I gave you? That is 1. So all that you did is initialize a value, and mostly we initialize it with 0. Then for each number, the value, your current value will be multiplied by 10 and added to the extra number that is coming in. So now this will give us y is equal to this. 0 times 10 is 0 plus 1 is 1. So y is now equal to 1. The next step, y will be equal to, we already have y being 1 already. So 1 times 10 plus the new number that we've been given, which is what? 2. So we end up getting 2 here. And this is 10 plus 2, that is what? 12. So y is now equal to 12. And the next thing is y is now equal to 12. So we have 12 times 10 plus the new number that we are being given, which is 3. And this gives us 120 plus 3, which is 123. So y is now equal to 123. And basically that is how you build a number out of this. In fact, this is coming from like the place value method, which we will analyze critically after in this third method. Okay, so for you to appreciate it, this is how the whole process is. But then we now know how to build the numbers. So that means that if I give you three numbers, say 3, 2, 1, and I ask you to build it, you know that you initialize y is equal to 0. The next one is y is equal to 0 times 10 plus, what is the first number there? 3. So this gives me 3. The next one is 3 times 10 plus, the next number is 2. So 30 plus 2, that's 32. Then y is equal to 1 times 10, no, sorry, 32 times 10 plus 1, which will give me 3 to 1. So if I could give you this number in this, I mean, give you this number, you know how to put it together to form this, okay? So essentially, if we are given 1, 2, 3 to reverse, we should think about how do we obtain the individual digits. I want 3, I want 2, I want 1. Okay, to be able to do that, we can use the modulo method. Modulo 10 of a number. So 1, 2, 3 modulo 10 is going to give me 3, right? That is 1, 2, 3 divided by 10. The remainder is 3. All right. If I want 2, then I should do 12 modulo 2. So how do I get rid of this? Let's say when we're starting, our norm was equal to 1, 2, 3. So we did modulo to get this 3. Then now let's update our norm. Let's get our norm to 12. But how do we get it to 12? If we do 1, 2, 3 divided by 10, in Python, we have what we call the floor division or integer division. Or if in any other programming language, you can do just division of integers, and it returns just the integer part of the division. So this ideally would have been 12.3, but then since it's floor division or integer division, it leaves us with 12. So our new norm is now 12. We can come and do 12 modulo 10 to grab the 2. Then we create a new norm, which will be 12 floor divided by 10 to give us 1.2. So we have 1. Then we now do 1 modulo 10. 1 divided by 10 is 0, remainder 1. So the remainder is 1. Okay, so you see what we've been able to achieve. We've been able to grab the 3, the 2, and the 1, but in these various steps. So basically, what we did is we had a modulo. We had a modulo to grab the required number. The required number. Then the next thing we did was to update the original number. Okay, the number that we had, we updated it by dividing by 10. Okay, so two things that we did in order to get the numbers. The first was modulo 10 followed by floor divided by 10. So whatever number modulo 10 followed by the number floor divided by 10, then we go ahead to do that again. So let's see how to implement this in code. This is just going to give us the individual numbers, and we are going to use this same method to string the numbers together. Okay, so over here, the very same function that we have created, but then the same thing. In the first place, we are checking if it is a negative number, and we return false if it is negative. Then we are going to make a copy of the number. So how do we make a copy? Just say num copy is equal to n. You realize that at the end of the day, we're breaking the number down. So we need to keep a reference of the original number so that we'll still have something to compare the reverse number with. Then we create a reverse variable, a variable for the reverse number, call it reverse num. So this represents like the y when I was explaining over there. Then we are going to use a loop to look through the digits. And when we look through the digits, our goal is to grab the last digit of the number that we want to reverse, as well as generate or update the number itself. So we are using the num copy that we created so that we can reserve the num for the final comparison. So wait, if num copy is not equal to 0, then what do you want to do? Our new number, do you remember this? We have 10 times the reverse number, then plus this. So if we go back to what I did originally, I did y is equal to 10 times y. Okay, that's what I initially did. Then plus the number that you were given, but then we are getting the number from the modulo as I showed you. So that's basically, if it is the first digit you are getting, that becomes 3 like this. Okay, and you have already set like y to be 0. So that is what is happening in here. The reverse num is equal to 10 times reverse num plus the modulo 10 of the number. Then we go ahead to update this number for the next iteration. So this while loop will run until num copy now becomes 0, then it stops. By the time num copy becomes 0, it means that we've grabbed all the individual numbers out of the number that we want. So now we can compare the reverse number that we've built here with the num that we were given to see if they are the same. So let's try it out and see. Python, this is palindrome 3. Okay, so run this and see. And it gives us true for 1 to 1. Let's change it to 1 to 3 and see. All right, that is 4. So basically, that is also working. Let's look at the last method. With the last method, as I said, it's with the place value method. So place value, if I give you the number 1, 2, 3, okay, there are a few things that you need to know about this. This is actually 10 to the power 0. It's multiplying 10 to the power 0. This is multiplying 10 to the power 1. This is multiplying 10 to the power 2. Okay, so essentially we have 1 times 10 to the power 2 plus 2 times 10 to the power 1 plus 3 times 10 to the power 0. That's how these numbers are built. You know, this is index 0, this is index 1, this is index 2. If you analyze them critically, with the help of their length, the length is equal to 3 in this case. So we'll get something of this. So 1 times 10 to the power 3 minus 1. That's the length minus 1. Then minus the index. The index of this was 0. Do we still get the same thing? 3 minus 1 minus 0. That's 3 minus 1, 2. Minus 0 is still 2. So we end up getting exactly what we have here. Plus 2 times 10 raised to the power 10 raised to the power 3 minus 1 minus 1. Okay, then plus 3 times 10 raised to the power 3 minus 1 minus 2. So all that we are doing is taking their indices, subtracting it from 1 minus the length of the digit. So at the end of the day, this gives us 10 raised to the power 2 plus 2 times 10 raised to the power 1 plus 3 times 10 raised to the power 0, which gives us 100 plus 20 plus 3. So 123. So in the same vein, if we can grab the numbers from behind, all we need to know is what is the length of this number. So if I give you 3, 2, 1, build a number using the place values, all you have to do is 3 times 10 raised to the power. What is the length of this number minus 1? And what is the index of this number? So if we are using a loop, you probably, let's say using a for loop, since we know the length, we would say I representing the index. Okay, so in this case, index 0, then plus 2 times 10 raised to the power length minus 1 as index 1. Then we have 1 times, was it, yes, 1 times 10 raised to the power length minus 1 minus 2. Okay, so essentially for each number given, if the number is y, we have y times 10 raised to the power the length minus 1 minus the index of that number, and this will be added to every other number in this form. Okay, so we can use a loop to iterate through that to help us get this. Let's go back to the code to check. All right, so this is the code for it, and as usual we are checking if it is negative and returning false. Then we'll make a copy of it, then initialize a new variable for the reverse num. But then the problem here is that we need to know the length of the number, but we don't have a direct method to or function to check the length of an integer. So we convert it to string, which isn't good. So this is not like an optimized solution, but just so you know how you can approach some of these problems, or from which angles you can approach some of these problems. That is why I had to go this route. So we have generated the length here into this variable. Then we are looping through the number using a for loop. So for I in the range of this, that means that if it is equal to 3, we are starting at the range function will start from 0, 1, and 2, end at 2 if your length was 3. So we have 3 characters in there, or 3 digits in there. Okay, then how do we build the value? We build it by adding the reverse value. That's a value that we get plus what we are grabbing. Remember this, we do the modulo to grab the number. So in the example that I gave, I said if you are given 3, 2, 1, but then no one is going to give you, you have to grab it from the number, and we are using the modulo to grab it as I explained in the previous example. Then we multiply it by 10 raised to the power the length of the number minus 1 minus the index, which I've already explained. But in Python, this is how you write it. Power of 10, then the power is len number minus 1 minus I. Then we update the copy of the number over here, so that by the time this has ended, this has gone through, we would have gotten each of the individual characters or digits in the number converted into this reverse number. Then we'll go ahead to compare the reverse number and the original number that we were given. are they the same? If they are the same, we return true. If they are false, if they are not the same, we return false. So now let's test that out. This is true. So when you run this, it gives you false because we are having a negative in front here. Let's take that negative off and run it again. We are getting true. Okay, take this away and put 3 there. Let's see what we have. All right, false. So this is like 3 different ways that you can solve the same problem, and I hope you understand it and the process in which I approach this. I'm going to be shooting a lot of these videos, so if you enjoy videos like this and you want to see more of it, give the video a thumbs up, leave comments if you have any questions, and I'll see you in the next video. Bye bye.